ladies and gentlemen. Did you guys hear that echo? Yeah, I think I know why. The echo because it's playing through the speakers. Anyway, I don't know. Not sure how to fix that, but it's okay. Does it kind of bother you, the echo? It's kind of weird, but anyway, let's take a look at some material here because I was thinking about it yesterday, like, man, this echo's going on. I might be able to, yeah, let's just do that. Okay, now the echo's gone, is that right? Let's see if we still have the sound. That sounds a little normal. That sounds better. Oh, wait a minute. I hear the echo here. Now, anyway, whatever. Why is there an echo? Okay, folks, let's just take a look at this stuff here. Let's look at the website. And sounds like I'm at a baseball game. So I'm going to look at this website. And we're going to go to 241 here. Now, remember, worksheets and video library. So I'm going to share with you guys something here that's kind of on this website as we update everything. Go scroll down to, it's actually down around here, but I'm going to probably move it when I get home. We're going to work on part of these here. Okay, so this is part of what I'm going to have you guys work on, and I'm going to put that in the chat here. So anyway, so if you guys go back and look at this, some of my students maybe in the trick courses have said to me that they do go back and look at these videos. Do you guys do that too? Anybody? You guys go back? Okay, good. Do you find it helpful? Okay, good. That's the whole idea. You find it helpful, you go back and you go take a look. So ladies and gentlemen, there you go. Okay, now what I'm going to say to you guys. Remember I said something like to you, probably one of the most useful classes you guys can ever take is this class, trigonometry. Okay, because it helps explain the world around you. So working with, as you guys know, I sent you some, whatever that's called, I guess, extra credit on right triangle information. That's really geometry in some ways, ladies and gentlemen. And now you're dealing with law of sines and law of cosines, right? So the applications are extremely important, ladies and gentlemen. The whole reason you do this is for the applications. So that's kind of my perspective on math is there's applications of it. It's just not this sort of game like Monopoly that exists and that people just don't use it, right? People use it all the time. It's extremely important. And this is why you guys are here to do that, because it has uses. That's the whole thing about this. If you don't, look at how to use it, it almost makes things meaningless to study, in my opinion. All right, so you might say, oh, okay, how do we use this? Well, let's identify this here, okay? So what I'm going to do here now is I have this for you. Let's transition over to the iPad. And that is weird. Oh, I'm going to get rid of that. Get rid of that. And I'm going to get rid of this because this is not a part of your class. This is part of another class. Okay. And so now we're looking at some applications. So if you guys looked at the law of sines homework, did it have applications there? Do you guys know what I'm talking about? Hopefully. Okay. Now, here's the thing. Let me see if I can scoot a bit. And no, this was in the iPad. There you go. All right, law of sines, applications. There we go. Now we're good. We're good. So let's take a look. Tracking a satellite, ladies and gentlemen. So this is kind of a tracking the satellite kind of situation where it says, if we read this, because you want to read it, The path of a satellite orbiting the Earth causes it to pass directly over two stations, A and B. And so here's kind of the story. Obviously, I put here's the satellite. Here's the stations A, station B. Now, the ground, as you guys can see, is labeled here. So they have that thing labeled as the ground. And so what do they say about this? They are 65 miles apart. So these satellites here are 65 miles apart. So we want to label that. This is 65 miles, okay? So I'm going to start to work with some of these things. So you got 65 miles. There's a reason why we study law of sines. There's a reason why we study solving triangles. This is the reason. So we're looking down here, ladies and gentlemen, and we have this distance that's given. And that's just in the information that they give us here. Okay, 65 miles apart. And then they say when the satellite is on one side of the two stations. So the satellite was moving. I guess it's moving in this direction. And now the satellite is on one side of both stations. That's what they're saying. Okay? The angle of elevation, now you say, what do you mean an angle of elevation? Do you guys remember the definition of an angle of elevation? That's an important detail. Okay, so you say, what do you mean? Why is that so important that you have this angle of elevation and it measures 70 and 80 degrees respectively? What's the definition? Do you guys remember? You have to have an eyeball. So at position A and B here, really on the ground, you're looking up at the satellite. Is that true? Remember the definition? So the ground level here and that path, this is ground. So you can think of this as L1 and this is L2. So they don't say the satellite is moving horizontal to the ground, but in the picture it says that. So L1 is parallel to L2, okay? That means that's really an important fundamental idea. That's extremely important. They don't say that, but that's what's going on there, at least in the picture. So you got these angle of elevations given to be both, 70 degrees and 80 degrees respectively. Is that right? And they even indicate that. So they're telling us this is an angle of elevation. The object is a satellite. So you're looking up, it's elevated. That's an extremely important detail. And then what are they asking here, ladies and gentlemen? What's question A? Do you guys see question A? What are they saying? How far is a satellite from station A? Yeah, what are you talking about? How far is a satellite from station A? So I'm going to highlight that. I'm going to say this. They're asking for that distance. Is that true? You guys with me on this? So for question A, I don't know what you want to call that. How far? I'm going to call that D. D for distance. You guys with me on that one? That whole idea? So take a look at that. I'm reading for question A. They're saying, hey, this is how far is a satellite from position A. So there you go. That's going to be distance D. All right. Now, believe it or not, this is an application of the law of what? Science. This is why you're here, to study this, ladies and gentlemen. This is why we're here. It's not just to learn the material that is independent of an application. The whole idea is to learn it so you can apply it. That's the bottom line, ladies and gentlemen. That's where the gold is. So, okay, you might say to me, how do I know, ladies and gentlemen, that this is a law of science question? How do we really know it's law of science? Wish I had my sound effects. I got to make that a priority when I get some time to kind of bring back my sound. And I might be able to, and just have some couple of buttons there. All right, what do we think? How do we know it's law of science? Didn't we have various cases for law of sines, right? If I look at this picture here, is there any angle I can find here so I can say that this is law of sines? Look at that angle. Do you guys realize I can get that angle from the picture? What's the relationship? How do I know what this angle is going to be? Huh? Good. It's what? Yeah. That should measure 100 degrees. Is that true? How do we know that's 100? Supplementary. Remember that? There's supplemental. That's a straight line. So remember what we did in that first week. I think I gave you guys some of that stuff. Is that right? And that's where the geometry idea comes from. Geometry. Supplementary angles. So you might say, oh my God, Mr. Judge, they're going to make me remember that supplementary angle? Yeah. Okay. Now you say, what am I really looking at? How do I know that this is law of sines? Anybody want to tell me? How do we know? Yes. Well, be careful. Be careful. Not angle, side. You're close. I understand what you're saying. There are two angles and a side, but what do we really call it? You're staring at it right here. This is really what? Angle. Sorry. What is that? What is this? Angle, side angle. Why is that an important detail? Because the side, ladies and gentlemen, of 65 miles is between two what? Angles. All right, you guys okay with that? You guys with me on this one? That is how you know that this is a law of sines situation. So law of sines is going to be a big deal. Now, this is not a right triangle now, is it? So what I sometimes have students do is they go back to right triangles and they no, that's not a right triangle. There's no 90 degrees. Remember, if this is an angle side angle situation, do you guys remember we can get that third angle easily? It's not really asked, but we may need it. I don't know. Do we need it? Oh, no. Yeah, I think we do need it. Don't we need that for angle side angle? Could you guys tell me what angle is that right in here? Because this is where we started our adventure into law of sines. We started right here. Do you guys remember when you get two angles, you always get the third? Isn't the sum of the interior angles of any triangle 180? So what does that have to be? It has to be 10 degrees. Is that right? You say, how did we know? Because 180 minus the 100 minus the 70 degrees gives us that 10 degrees. So ladies and gentlemen, we know that this measures 10 degrees. That is necessary for us to work and find that distance. So we need this. Ladies and gentlemen, this stuff is doable. You know, I always tell students this because it's true. And I know when I was a student, I never knew this. Nobody ever told me. I had to discover this myself, right? What do you think I was doing on Easter Day besides praying to my, well, it's not a religious course, but, you know, I was praying that day. But besides that, what else? Because it's Easter, by the way, right? Yeah, I spent a little time with family, but, you know, I was working. I remember writing this letter of recommendation for a student of mine. He's a STEM student. He's going to get into this UCLA summer program. He's a very good student. But you want to know what makes him a good student? He started in elementary algebra. You want to know what makes him a really good student? You want to know what makes me really impressed by this kid? Yeah, I had him for Calculus 1 and Calculus 2. And this guy is, how should I put this? He understands how to do things. You say, what do you mean? He has that strong desire to succeed. So he does his work. He follows up. You know, he does what he's supposed to do. He does everything he's supposed to do. This kid is fabulous. So, you know, I need to write a letter of recommendation for a summer program. You think I'm going to spend my Easter writing that letter? Absolutely. You guys see what I'm saying? You don't stop working. That's my point to you guys. You don't stop. It never ends, even on Easter. It's a matter of, what did Jaime Escalante call that? Do you guys know what he called that? It's very simple. It's called ganas, desire, will. And if you have that, you can do anything. Will. Get that will. He has that. He has that. So that's what I put in the letter. I actually put that stuff on my Easter break. It's all good. So, okay, ladies and gentlemen, do you guys want to get that will? How do we get that will? That's the secret. How do you get that will, ladies and gentlemen? Do you guys know? I don't know. For me, I just decided to do my homework every day. I said, you know what? I'm tired of fooling around. I didn't play with Xbox. We didn't even have Xbox. Sony PlayStation. Just said, you know what? I'm gonna do my homework every day. That's what I'm gonna do. Tired of fooling around. So this is how this kid is. He's an amazing kid. All right. What does law of sine say? Do you guys remember? Don't I have opposite right here? Let's do this here. I have an angle and I have an opposite side. So what does that mean? Sine 10 degrees over what? 65. What does that equal? Oh, I have an angle and I have an opposite side. That is sine of what? 70 degrees over what? Over D. Do you guys remember doing some of that for homework? Cross multiplication? Do you guys remember that? Proportions? How does that work? Right? Remember, this is going to be D now. Sine 10 degrees becomes what? 65. Sine 70 degrees. What happens now here, ladies and gentlemen? Sine of what? 10 degrees. Sine of what? 10 degrees. That goes away. What does your D become? Right? So I'm going to cancel that because it went away. We canceled that. So there's our D, ladies and gentlemen. What does that give you? We're going to have to get out the TI calculator. Mode, look for degrees, okay? Are we in degree mode? You guys know what might happen one day? You're in the wrong mode of your calculator. We're in degrees. Okay, we're going to hit what? 65 sine of 70 divided by sine of 10. So what is this D going to be? Do you guys know? Let's go out to the nearest whole number. Is that 352? Okay, 352, ladies and gentlemen. Right? We entered this in the calculator. We made sure that it was in what? Degrees. So 351.7 is about 352 miles. Ladies and gentlemen, there you go. There it is. So we know that that distance is 352 miles. So ladies and gentlemen, let's get rid of all of this distraction here, okay? So we just found this to be this distance, 352 miles. This distance right here. And all because we know law of what? Sines. Easy peasy, lemon, what? Squeezy. All right. All right. What does this next one say? You guys see that? What's question B? What is the altitude of the satellite above the ground? So, we have to talk about this stuff because, sometimes people might even say, hey, Mr. Judge, what do they mean by altitude, right? What do you think they mean by the altitude of the satellite? What is the definition of altitude? It's like, it's not just, well, yeah, it is height, right? But be careful about this because I was one of those kids who I was like, what do you mean by height? You know what you mean by height, ladies and gentlemen? That was me. You know what they mean? See if I can draw this here. This here is the altitude. I'll call that A. Okay, and I'm going to move that 352. This is 352 miles. There's your altitude. You want to know what I need to do, though? I want to make very clear about altitude, some very important fact. You know what it is? That this is a corner. You see, if you ever want to know about altitude, it is a strictly vertical height. Do you guys know what I'm saying? Vertical. It's not a diagonal. We just found a diagonal. 352 is the diagonal. So you might say, well, what do they mean by an altitude? It's a vertical height. So this is an important detail. Why do I want to point this detail out? What does that mean? That means this is a what? 90-degree angle. Is that right? Why is that important? Because they're asking us for the what? For the altitude. This is A now. So question 2, or B in this case, is what's the altitude? So they're going to want us to have that height. Ladies and gentlemen, why did Mr. Judge do that assignment over spring break? Well, 2 reasons. I think it's unacceptable to people to not know how to solve a right triangle. It's unacceptable. That's how I really feel. Unacceptable. Not only that, second reason is because take a look. I use these things. We use these things to get answers. I can use my right triangle information, ladies and gentlemen, to do what? To answer this. What do I mean by that? Let me get rid of this. Do you guys happen to see a right triangle anywhere? I see one. Do you guys see it there? Look at that. What am I going to use to find the altitude? Anybody remember? What is it? What do I use? You guys did the assignment. It's going to be what? Right? I'm going to have to erase this. So it's in the video. I wish I did something with this. So I'm going to have to dig this out. I wrote this years ago. Anyway. What do we use? What's the definition? We have the angle 80 degrees, right? And then we have what? Opposite hypotenuse. Oh, isn't that sine? I'm not awake yet. Sine 80 is A over 352. So in other words, I just go back to geometry. A right triangle. And can I solve for A? How do you solve for A? What does A equal? 352 sine 80 degrees. So, ladies and gentlemen, this is why I did what I did, because I do know you're going to have to use this to do an application. Meaning 352 sine of what? 80. And guess what I'm able to get, ladies and gentlemen? Now this is the altitude. What's the altitude going to be? Let's go to the nearest whole number. That's 340 what? Let's go to the ones position, right? The decimal to the right is a 6. What does that mean to do to the decimal to the left, which is also a 6? Add 1, and what do you guys get? 347 what? miles. That is your altitude. So, ladies and gentlemen, we have used right triangle information. 347. We should put miles. I just want you guys know it's miles. We use right triangle information to find the altitude based on a couple of measures. So based on a certain amount of measures, we can deduce altitude. And that's how, this is why you guys are here to do this in a trig course. It's kind of like a major idea behind trigonometry. So when you go to other classes, that have a prerequisite of this material, there's an expectation. You guys know law of sines, law of cosines, and how to do these applications. That's the expectation. Because now what you're there to study in some of those other courses is actually how to use these things. That's the whole idea. This is why we do what we do. So I'm a person, if you guys notice, you say, boy, that Mr. Judge, he does work on applications. Yes. Why? Because I know where you're headed, you use them. That's the whole idea. And yes, you might want to get used to this idea. Like I'm saying, you never stop working. It just doesn't end. I used to, as a kid like you guys, I used to think, oh, one day I can't wait to stop working. I'm still waiting for the day. That day hasn't came. Even on Easter, writing a letter of recommendation. Between praying, spending time with family, I got to knock out that letter. Doesn't end. So embrace it. Get used to it. What do you guys think? Isn't that everything we worked on? I think so. Did Coach ever do that kind of stuff? No? What did Coach do? Just throw the ball around in the classroom? Just hang out with everybody? Give everybody a high five? At least give people Flamin' Hots or Snickers? Man. Should have been Coach. Darn it. Yeah, it's funny. It's kind of interesting. I used to bring my daughter. My daughter, when she was a little girl, back then in the day that we're talking about, it's a different time. Students would come in on a Saturday. They'd want you to come in on a Saturday to help prepare for a test. They would say, oh, Mr. Judge, can you please come in on a Saturday? We're going to have this test. And that was common back then. This is like 20 years ago, ladies and gentlemen. Times have changed. And so you'd come in, and then sometimes, to have my daughter sit there because, who's going to watch her on a Saturday? So I'd bring her in. She'd sit there and she would just watch, She learned how to take notes. That's how she learned how to take notes, just coming with me on Saturday when I'd lecture. And so she just got into that habit. It's weird. It's weird how you pass that stuff on to your kids. So she was taking notes. She used to bring her in. So she learned all those little things. And then some lectures I'd bring her in, not even on a Saturday, but some lectures. And if I was like a 2 or 3 minutes late or 5 minutes late for a lecture, you know what would happen? I walk in the room with my daughter. You know what you would hear? You'd hear this sound like, oh, meaning, oh, he showed up. And my daughter was like, Dad, why did they react that way toward you walking in a room? Oh. So I explained to her, well, sweetheart, no, it's not that they resented your dad being there. It's just, they thought they had a free day and they didn't. I don't know. I think that's a funny story personally. So she learned this. Oh, it's funny. I don't know. Interesting. Here's another one of my favorite examples, ladies and gentlemen, the flight of an airplane. That's very, very similar to what this was. Very similar questions. They're all applications for law of sines. And then we'll see law of cosines. So here's the deal for flight of an airplane, right? And I know that it's an extremely important thing to read through it and even see the picture. Because sometimes there's details they don't even tell you as you read, and you want to talk about those details, right? Like, for example, the flight of a plane, they don't tell you that it's flying horizontal to the ground. They don't tell you. So here's what they say. The flight of a plane, they're saying a pilot is flying over a straight highway. They just say straight highway. And you go, what do you mean by that? All they mean is that the flight path here and the ground level here, 2 lines again. Call it L1, L2. These lines are what? These are parallel, ladies and gentlemen. That's what they're saying. So they don't even say that, and I wish they did, but okay, a pilot is flying over a straight highway. Okay, there you go. And you know, the reason why I put this phrase horizontal, because that's related to a couple of things, but I just want to communicate to people that those are, or horizontal is parallel there. He determines, or she determines, the angle of depression. Now, when they use the phrase angle of depression, what are they talking about? Because that's an extremely important detail too. What's an angle of depression, if you guys remember? The definition of which. If it's an angle of depression, your eyeball is above the object. So this is the eyeball of the pilot. So now the pilot's eyeball is there. And now you need an object. And you say, what are the objects? To 2 posts. When I read this, I'm like, what's a post? I don't know. What's a post anyway? It's just like an object, I guess, on a highway. So in other words, you got 2 posts. And again, here, the pilot is looking at post A, post B, two posts. And the pilot says they're 8 miles apart. You go, oh, so this distance is what again? 8. You guys with me on that? So the pilot is going, okay, I got 2 posts 8 miles apart. And you got these angle of depressions that are 35 and 46 degrees respectively. So remember the definition. Horizontal, we already have labeled. To the object, that angle is 35. The other is 46. See, you're not free to put your angles anywhere you want. The definition of angle of depression and angle of elevation is in play. Remember, in both cases, you need a horizontal. You need an object, you need a horizontal. And it's the angle between the object and the horizontal. And so you might say, oh, what is that? Well, here's the object between, here's that line, because your eye sees things in a straight line. So this is why we know it's 35 degrees, it goes there. And this is why we know over here, between the horizontal and that line, it's 46 degrees. So the picture is consistent here. And I'm going to make the claim here, ladies and gentlemen. This is, again, law of sines. How do we know it's law of sines? What situation do we have for law of sines? Remember, if you go back to our law of sines work, law of sines, where are you? Okay, law of sines. We got side angle, the ambiguous case. That was law of sines. Go back from the beginning. All that work we did. I think I have it way up here. We have it here. Where is it? Oh, here we go. It applies to what situations, law of sines? Angle, side angle, or side angle. This is the essence of law of sines. So what I'm saying is, how do I know that this application question is a law of sines? Because it's not clear. It's not clear. What are my angles? You guys say, but the angles are outside the triangle. Let me change my colors. Green. What's this? Orange. I'm going to change those colors. You know what I'm going to make the claim is? I know what this angle is. It's green. I know what this angle is. It's orange. But my question to you is why? How do I know that? Now, there's a reason. And we actually worked on it. There's a very good reason, ladies and gentlemen. Let me do this. What are you really looking at? Here's something here. What are we really looking at here? Oh, that's weird. What is this? Isn't this another line? But why am I using all of this important detail? What is this really? It's a transversal. Yes, that's the whole idea. So the stuff we already worked on is right here. You remember that? A transversal? So what this says to me is that this is 35 degrees. And in fact, if I say, okay, there's another line here, that means that this has to be what? 46 degrees, because we're looking at two transversals on top of each other. So this is transversal information, if you guys remember. Did we work on transversals? Yes, transversals. So why does law of sines come to mind? Because notice the question they're giving you now, right? Let's get rid of all of that. What do they want to know? The first question is, what is the distance of the plane from point A? This is what they want to know. This is D. Because the plane is here, point A is here. So for question A, we're labeling that D for distance. What kind of situation are we really looking at? Now we know what it is. What is this? Because you got to identify that. If you don't identify the situation you're in, you're not going to know whether you use law of sines, and you haven't looked at law of cosines yet, but we will. This is angle, side, angle. Good. How do you guys know you have angle, side, angle? Angle, side, what? Angle. So do you guys think that's important work to do, the angle, side, angle? It's very important. This is what's done, ladies and gentlemen. This is how you do this. Okay, so law of sines comes into play. Anybody have any questions on what we just did? We're using transversal information. Here, earlier, we used supplementary angle information, that straight line, supplementary angles. And then we used the right triangle. So this is what's going on. This is a study of triangles, ladies and gentlemen. So, okay, what can we say? What is needed for angle, side, angle? Don't we need another angle? What's this angle right in here? Anybody know? What's that angle? How do I get that angle? Isn't that 180 minus 35 minus what? 180 minus 35 minus 46 degrees. Okay, so let's do that. And, oh, it's a 99-degree angle. All right. There we go. Now we could use the law of sines. Is that right? Remember, angle, side, angle, you get that. I'm sorry. Yeah, angle, side, angle, you get the third angle. All right. Okay, folks, let's try this out. What does that mean? That means what? Sine 99 degrees over what? 8. What does that equal? Sine 46 degrees over D. Does anybody remember why we do that? Because we have an angle and we have an opposite side. That's how law of sines works. And then you have an angle, and then you have the unknown D. So we got 3 knowns, 1 unknown. That's going to allow us to solve. That is the law of sines. You guys are looking at it right there. So how do we apply it? Do you guys remember? Cross what? Multiply. D. Sine 99 is 8. Sine 46. How do you guys solve for D? Sine 99, divide that from both sides. Okay? Cancel, and now D becomes 8 sine 46 degrees over sine of what? 99. Let's see what D is approximately. Let's get that out, okay? And you get your TI now. Okay, TI, here we go. So here's the deal. 8 sine 46, close that, divided by sine of what? 99. What do you guys end up with? Let's go out to the nearest whole number again. I feel like in the whole number mode. 6. Was this stuff in miles? Yeah. 6 miles. Okay. So, ladies and gentlemen, we got 6 miles here. We found that distance. It's really 5.8 or something, but we're going out to the whole number. Maybe we'll go out to the tenths. I don't know. On a test, I'll tell you what to approximate probably. And ladies and gentlemen, there it is. Easy peasy lemon squeezy. Right? If you remember transversal. All right, let me erase this here because take a look. What's the next question? Do you guys see the next question? Yeah, it says find the elevation of the place. Jesus. Of the what? Of the plane, not the place. How do you think, what do they mean by elevation? What's the elevation again? Do you guys remember? It's a vertical line. That means this has to be 90 degrees. This is A for elevation. So the next question in B is to find the elevation. I call that A for elevation. So I'm going to get rid of this, and I'm going to remind you guys here, now you have a way to find a vertical distance there, the elevation. How do you do that? Does anybody know? Do you see what I see? What do I see? Do you see a right triangle? Do you guys see a right triangle? So how do you use that right triangle now? I'm going to erase our law of sines because we don't have a lot of space. Yeah, what's the definition? Do you guys know? Sine of 35 degrees. What does that equal? Opposite over hypotenuse. Okay, that's why we did that stuff. Where's that coming from? Is that me? You guys hear a noise? Sounds like email, but I don't have my email. I don't have my email on. So what is A going to be? A is sine 35 degrees. Is that right? So not A is 6. 6 sine 35 degrees. Close that up, ladies and gentlemen. And, you know, it's, you know what? I don't feel, oh, whatever. I should have been more accurate, but we'll go with this, okay? I apologize. I would rather have been more accurate, but it's a very crude computation. So, okay, E is about 3 miles if we go to the nearest whole number. On a test, I'll say like the tenths at least. Okay? So, altitude's about 3 miles. It's actually not, but okay. Very crude, but you guys see the point. You can now adjust your accuracy any way you like. These are all approximate. So, ladies and gentlemen, this is how we apply what we've learned. Okay, these two very, very relevant and important examples is how you apply what we've learned here. Height of a tree, calculating distance of a balloon. Oh, this is another one of my favorite kind of things. Here's what I'm going to do now, ladies and gentlemen. Back home is typical. And so what I'm going to do now is this. I think we skipped a few. Is that right? Let's go back to some of these questions here because as you guys can see, I really did update this for you. I put some nice what? It's nicer. Doesn't have the scratch. So I did update all of that. Also, let's do the height of a tree here, okay? So we didn't do this, but this is actually back from law of sines applications. This is a very important kind of question because some of you guys are going to be taking classes that have maybe some of these things, okay? All right. Okay. So let's go through and take a look. A tree on a hill casts a shadow 200 feet down the hill. So what is the deal here, right? So you got the tree, you got the sun, and notice the difference here. Here's my shadow, okay? So let's make it darker. It's 200 feet. Here's the shadow. So a tree on a hill casts a shadow 200 feet down the hill. Notice this is not a right angle, is it? This is not like the right angle. This is now reality. You can have a tree on a hill and it casts a shadow. If the angle of inclination on the hillside measures what? 25 degrees. Now let's talk about this. Angle of incline measures 25 degrees. This is your incline angle. This is what they're talking about here. Okay, so I want to go through the information. So that hill, in order to have an incline, you need to have a horizontal, and you do. So this is defined here. This is kind of new for you guys. They gave you an angle of elevation, but there's a line there. This is why I drew the horizontal. And so what they're referencing here is that's a 25-degree angle, the angle of incline of the hill. It's inclination, right? Angle of incline measures 25 degrees. You also have an angle of what? Angle of elevation to the sun. How do you get that? How do you get an angle of elevation to the sun? Right? Remember this? They say it's 55 degrees. So what I did here is to remind you that you need a horizontal and you need the sun, and you have it, the object, The eyeball is on the ground. You're looking up at the sun. So this measures, okay, with the horizontal, 55 degrees. So I want you guys to understand this here. This is 55 degrees because you need a horizontal to measure the angle. Has to be horizontal. And so that measures 55 degrees, which is why I put the picture the way it is. Okay, you guys okay with that? Okay, you guys okay with that? So notice what they're asking us for. They're asking us for the what? To read, find the height of a tree. Find the height. What's the height? The height is what? H. Sorry. So your height is over here. Here's H. So I want you guys to digest that, chew on that, see what's going on with that, okay? Because you're going to have to find the height of a tree here, and, you know, you're going to have to use some skills to do that. Okay? So what I'm going to do here for you guys is this. I'm going to draw another picture of a triangle. So that you can hopefully see this is your situation. This is what you guys see that you have so far. Is that right? You got a height. You got that distance, 200. And that's what you're looking for. Okay, you guys okay with that? Now, I think you need some angles. Don't you need some angles? So how are you going to find some angles? Yeah, you're going to need some angles, right? So I make the claim, you know what angle I think you could get? You guys can get this angle here and that angle here. So let me go back again. I'm going to make the claim. You guys can get this angle and this angle. What are the key ideas you got to remember? What's the word I want to use? You're going to think about a what? What? Reversals. Key. So you might go, what are you talking about? Well, there's a line here. We'll call that line 1. And there's a line over here. We'll call this line 2. And then you go, what's going on? Well, you got another line, if I can get it there, hopefully. L. Okay, you guys okay with that? And I'm going to do even this. I'm going to say you even have another line here, maybe. If I can kind of draw it. Let me change the color. And I'll call that, well, we can say this here is line maybe 3. And this will be line 4. And there's various ways to do this. So can I ask you guys a question? Focus on this one. Maybe this was something you could get right away. If I know this is a 25-degree angle here, this is 25 degrees. Is that true? You guys with me on that? That's 25 degrees. And then what angle is here? This is what? Isn't that a right angle, 90 degrees? So take a look. I'm saying this is in blue. Those are vertical angles or opposite angles. Doesn't that measure 25 degrees? So there's 25 degrees. Those are vertical angles. 25 degrees plus 90 degrees is going to give you what? What's this angle here? Right? This is going to be now 100 and, well, let's find out. This is 25 degrees plus 90 degrees, which is 115 degrees. Okay, so remember, in blue, 25 degrees. Opposite angles, 25 plus 90 is 115. In fact, what else do I know? That this here, because of a transversal, this is also what? 25 degrees. And that makes this angle also what? 25 degrees. Let me put that line there. So in blue, that 25-degree angle, the angle of incline, is being used here. So, I don't know if I can make that there, clear 25. This is 25. So what does that mean about my triangle here? Right? I can now get this angle over here as well. And I'm not sure what color, but I want you guys to know that if this whole thing is 55 degrees and this portion in blue is 25, what does that mean this has to be? This has to be what? 30 degrees. You say, how did you get that? Well, the angle of incline for the sun is 55 degrees minus the angle of the sun, angle of elevation is 55, angle of incline was 25. So this is how we got the 30 degrees right in here. That 55 degrees minus 25 degrees. So that's going to give you 30 degrees. And so guess what, ladies and gentlemen? You should be very happy. You say, why are you guys happy with this? What kind of triangle are you guys looking at now? Right? This is going to be what? Angle, side, what? Angle. So for angle, side, angle, what's the story? Is that law of sines or law of cosines? It's law of, I wish I had my sound effects. Is there anybody at home that knows? Is this law of sines or law of cosines? Which one is this? Law of what? Is that law of sines, law of cosines? Which one is that going to be? Remember, you don't start working on applications. You start working on law of sines first, law of cosines. And if you don't know which to use, then you need to start working on that. Because your test day's coming, and ladies and gentlemen, we test you. It's the way it is. Thank you. Law of what? Sines. Good job. So remember, if you have what? Two angles, are you going to get a third angle? How do you handle this situation, right? This situation is handled how? By law of sines. You got to get now the third angle. So what's your third angle? 180 minus the 30 minus 115. So that's 180 minus 145. What's 180 minus 145? What's that going to be? What is it? 35 degrees. Now you say, why do I need this? Because law of sines now is applied. What do you guys get from law of sines? This is going to be what again? Sine of what? 30 degrees over, remember this, sine of 30 over h, okay, is going to equal what? What's that going to equal? Sine of 35 over, here's sine 35 over what? 200. Okay, so this is your law of sines question. Now, what happens now, ladies and gentlemen? You're going to do what? Cross multiply. And you're going to end up with what? 200 sine 30 is h sine 35. And I'm going to need some space, okay? So what I'm going to do now here is this. Let's get some space. Double check to see if my work is okay. I'm going to need some space. I'm going to put it up here. Now, divide both sides now by what? What do you guys divide both sides by? Right, sine of 35 degrees. And you get cancellation. So h is going to be 200 sine 30 degrees over what? Sine 35 degrees. So what is h going to be? Okay, what do you guys get? We're gonna try that out. And let me go back here if I can find it. What is this going to be? 200 times sine 30. Close that. Divided by sine 35. And you end up with, what is h? 174.3. Is that right? All right. Good job. So here you go. And is that in feet? That's in feet. So, ladies and gentlemen, you found the height of the tree. I guess that was green here. So this is using law of sines applications, but the point I want you guys to know is you need to identify what's the situation. Angle, side, angle is law of sines. Side, angle, sine, angle, SAS is law of cosines. So that is that's the height of tree example. Okay. Now we have a very similar kind of question because now we're on a hill and this is more real now. We call right angle trig, which is really geometry. Okay, right angle trig, which is really geometry, ladies and gentlemen, is limiting because you could now have a hill. You could be on a hill. Remember, the right angle just means you have a horizontal ground. It's flat, and that happens. But you also have hill situations. So let's read this here because this is important, right? This is calculating distance, observers P at P and Q. So in other words, you got eyeballs, okay, this is where point P is, and this is where point Q is. You got some eyeballs there. P, Q, your eyeballs are here. There it is, P and Q. On a hill now. So what do they measure? Observers at P and Q located on the side of a hill that is inclined. This is a hill incline again. Oh, you got an inclined hill, 28-degree incline. Where did they reference that? You guys know? That's right here. So let's kind of be careful here. And I want you guys to really understand this here. Because like I said, where you guys go and the courses you take are important because you're now taking a prerequisite for other courses that need trig. And so they expect you to understand some of these things. So just to kind of remark, this is a line. This is a horizontal. And in fact, this is another line. So I can say L1, L2, L3, where all of these lines are parallel, okay? They never cross. So the incline of a hill is just how steep it is. So you're going to say, do you mean they're measuring? I'm going to put another line if you want to call that L4. Has to be a line though. So in some sense here, this is a fourth line and it's not parallel, but this is the essence of the incline of a hill, okay? So you guys know these are some things that you may not know, but we got to talk about, right? This is why I'm talking about it. This is an incline, 28-degree incline hill. This is important for you guys. All right, you guys okay with that? It's the definition of it. So you have a hill that's on an incline. Okay. What else is going on here, right? So you made two, they're going to say now here, the observer at P now. So you now have an observer at P, has the angle of elevation of the hot air balloon. So it's going to be 62 degrees. So at P, you might say, what's the angle of elevation? Well, notice what I did. 62 degrees here, the observer at P, but how do you find really that angle? You're looking at here, you're at P, and you're looking at the balloon here, okay? And that means you need a horizontal. The definition, remember, is right in here. That you need the horizontal. This is why they gave you that horizontal here. This is for that angle of elevation for P, right? For the balloon here. So hopefully you guys see that. That's the point. And if you read further, they're going to say what? At the same instant, another observer at Q, okay, measures the angle of elevation to be what? 72. So you go, where is that? Okay, now you're at Q here. There's an observer here looking at the balloon. You go, okay, they're both looking at the balloon. So you go, well, what's the 72 degrees? Why did you put it right in there? Because again, you need a horizontal. And this is why there's two horizontals here. Okay? So this is a horizontal for the next point, right in here. That's why I put it down there. Easy breezy, lemon squeezy. You guys see my point? I'm just using definitions of angle of elevation. And then now you know what an incline is. But you need a horizontal. So this is why you have these horizontal lines. And some books, like you might see in your future, they may not draw those nice horizontal lines. You have to draw them yourself. So sometimes some of these questions don't even have all those horizontal lines like I drew for you guys. But you need them to define angles. Angle of incline, angle of elevation, right? So P and Q, now you go, what is going on with P and Q? Well, if P is 50 meters downhill from Q, so P is downhill. Okay, we did put P is downhill. And what else did we do? We're saying that this distance is 50 meters, right? You with me on that? So I'm going to, yet again, if you guys can see this, they're going to want to know what? Find the distance from Q to the balloon. So what are they asking? Find the distance from Q to the balloon. So if Q's here and the balloon's here, they're trying to find what? This is what they're asking. Okay, find the distance from Q to the balloon. Now, what I'm going to do here for you guys is this. I'm going to draw again another triangle. And that's kind of what it really looks like, maybe. This is what they're saying is D. Is that right? This is 50 meters. I'm going to make another claim, ladies and gentlemen. You know what claim I'm going to make? Can you guys find some angles? Like maybe this angle here and this angle here in this picture? Here's what I'm saying. Maybe you can find that. Maybe, again, you're going to have an angle, side angle situation. Maybe, again, I suspect. I know one thing. How do I use the angle of incline information here? Right? How do I use that? You see this portion right here? I'm going to put this in red. What angle is this angle right here? Because that's the first angle I can get. How do I know? You see the 25-degree angle? I'm sorry, 28-degree. See this 28-degree angle? Isn't that angle, that's the angle of incline. Isn't that right here too? 25 degrees? Isn't that the same? That should be the same, is that right? You say, why? Because I'm going to say to you guys, L2 and L1 are parallel. So we can find that angle if we take what? The 62 degrees minus the angle of incline of 28. Because that angle of incline is right in here. Let me see if I can get the blue. That angle is 28 degrees. So the total, 62 minus 28, what is 62 minus 28? Right? Do you guys remember? So you're going to get that 62 minus that 28-degree angle. And what does that give you? 34 degrees? There's 34 degrees. So I have one angle here. This is that 34 degrees. Let me write a nicer 4. And then I'm going to ask you guys this question here. How do I get this angle now? Like I'm saying, here's where we're at. How do I get that angle? Can I get that angle? I think I can. Can I mention something to you guys here? Let me see if I can get rid of this highlighter. Okay. Can I say to you guys that what? Let's get rid of that. I want to keep this green though. This whole thing's 72. Can I ask you guys, let me find another color. What is this angle? Anybody know what that angle is? What should that angle be? I'm talking in gold or brown. What do you guys think? Is it 118? How do you know it's 118? Yes. Isn't that what? Straight angle? 180 minus what? 72. There's your straight angle of it's 108, I guess. Is that right? So I guess it's 108. Be careful. So that's 108. Is that right? You guys okay with that? See if you can get the picture. Isn't there a straight angle? You're using that red line, that horizontal. Okay, you guys know what I'm saying? You got a straight angle here. Supplementary angles. It's going back to geometry, those stuff we did the first week. That's why we spent some of that time giving you guys those definitions. And then notice this. I make the claim, ladies and gentlemen, that you guys know this angle as well. Because why? That angle is the same as this angle. Is that true? Aren't those vertical angles or opposite angles? What angle did I color in blue? It's also right here. It's also where? Do you guys know what angle that is? What angle is that? You see this 28 degrees? Isn't this also 28? That's your 28 degrees. Isn't that the angle of incline? So this is the angle of incline because they're vertical angles. Is that true? Yes. So if I know that, okay, here's what I'm saying to you guys. You can get this because you have 28 degrees plus the 108 degrees there. You're using the angle of incline. This is also what? 28 degrees because the lines are parallel. L3, or actually, yeah, L3 is parallel to what? Your L1. All three lines are parallel. So this angle is going to be now, what is that? Is that 136 degrees? 136. And I guess I colored them red, but let's do that. So like I said, we can get that using vertical angles and transversals, just opposite angles and transversals. And now you have what we're saying, angle, side angle. And again, what do we say? If you don't know what angle, side angle is, you don't know what to apply. So angle, side angle, this is law of what? Sines. But you have to always start by doing what? I'm going to get rid of this. You're going to get that third angle to use law of sines. So what is that third angle? Do you guys know? Isn't that third angle going to be, we're looking at this, 180 minus the 34 minus the 136? So we're going to do this. 180 minus 34 minus 36, because the sum has to be 180. And I think that's 136. And what do you get? This measures what? 10 degrees, ladies and gentlemen? Is that true? So 180 minus 34 minus 36. And what you guys now have is what? All right. So, yes, let's get rid of that here. So, ladies and gentlemen, you now have all the information you need for law of what? Law of sines. You can now get what you need, meaning we know what? Sine 34 over D is going to be what? Sine 10 degrees over 50. These two are opposite. That's what you're using. These two are opposite, and that's what you're using. Right? So now, what do you guys do? Cross what? Cross multiply, and you get what? 50 sine 34 degrees becomes d times sine 10 degrees. Divide both sides by d. D is going to be what? 50 sine 34 degrees divided by sine of 10 degrees. We're going to see what d gives you. Okay, we'll see what d gets. So let's try this out in the TI. $50 sine of what? 34 divided by sine of 10, and you get now what? 161 point, actually 0. Right, if you go to the nearest tenths, the 0 is in the tenths position, digit to the right's a 1, so your d is 161. So this is what they're asking here. I guess it was purple. 161 meters is that distance there. Okay, you guys okay with that one? And there you go, ladies and gentlemen. So this is what they're asking. The distance from point Q to the balloon. I can't get that. There you guys go. So now I would say to you guys, just thinking of something that can be maybe done. Angle. Yeah, there we go, ladies and gentlemen. So we have completed what I would say to you guys. We did this too. We did all these. Notice I did do a nicer version, like I said. There's no chicken scratch like I had before. So I did update this particular no chicken scratch. We did all of these here. I will actually edit a video here that has all these pieces of information. We did this yesterday. But we did it with the other worksheet. We have a cleaner one today. But I wanted to go back and find that error we had yesterday so we can be complete. And so, ladies and gentlemen, yes, thank you. We are what? We are done. Is that right? Anybody okay with that? Anybody have any questions on these here? What do you think the big lesson is? What skill sets do you have to know to do these? Number one, you got to know law sines, law cosines. Number two, you got to remember the transversals and supplementary angles, even complementary angles. Just those two things, okay? After that, you got to focus on the language, like you maybe learned new today, angle of incline, the language of angle of elevation. All of these require what? They require horizontals. So this is why in my sheets, I put that there. But in your book, did they draw the nice horizontals like I did? No. You guys see what I'm saying? So how I look at my examples is really, ladies and gentlemen, preparation for how you do your homework. That's how it should work. So my examples are really that preparation for the homework. Your homework is not going to draw the nice horizontals like I did. But I want you guys to know they're there, even though they don't draw them for you. If you ever have an angle of incline, you need a horizontal. Angle of elevations, horizontal. Angle of what? Depression, they all need these things. I'm even going to label that horizontals. Doesn't let me. Doesn't let me write. So if I can't write, I guess we have to go home. So all of them need these horizontal lines here. So that might be something that you guys didn't know or realize. So I just saved that at the very end here, but these are really law of sine applications. And that's why you might see it in the law of sine application homework. And you'll see these others, like starting here, calculating distance, those are law of cosine applications. Navigation, typically law of cosines. Reckoning, dead reckoning, and like we did, those are law of cosine applications. So you now are able to do your homework on law of sines, law of cosines, and applications. Remember, I did give you guys some extra credit. The reason I did that is because hopefully some people get motivated to do their what? Their homework. And that people understand that this is the essence of why you're here. This is trigonometry. Yes, you use some what? Algebra, and yes, you use some geometry, but you do use those things, and this is how you use them. So hopefully you guys are good. All right, you guys okay with that? All right, now you guys can go home and get started on your, hopefully get finished on your, not started, get finished on your what? Homework, law of sines, law of cosines. We'll see you guys tomorrow.